Today, we are going to deal with quadratic word problems. So things like throwing a ball into the air, for example, and then exponential and quadratic expressions and how we can solve for a missing variable. So the first thing that I want to talk about is just your compound interest formula. This is not a formula that's given to you on the SATs, but it is something that's kind of worth knowing. And so basically, what compound interest is telling you is that the amount of money in an account is equal to the principal or the initial investment times 1 plus the interest rate divided by the number of times it's compounded per year, raised to the number of times per year times the number of years in terms of the power. So here, this principal investment, you can always find that. Like if you have an equation like this and you're trying to figure out what the initial investment amount was, you can just plug in 0 for t because that's telling us if no time has passed, how much money is in the account. So we are going to start with an example where we're given the information in terms of the equation. So we don't actually need to know this equation for the first example. It tells us that we invest $1,000 into an account and then it earns interest based on the equation below. So essentially, this is like saying it's 5% per year because it's 1 plus the rate of 5% divided by 1 time per year. So here it says after how many years will our investment have doubled? So we can figure that out because we want our amount to be doubled. So $2,000, that's equal to the 1,000 times 1.05 to the t power. So we want to isolate that exponent so we can divide both sides of the equation by 1,000. That'll give us 2 equals 1.05 to the t power. And then remember, to bring an exponent down to base level, we need to take the log of both sides of the equation. And we can do that with the natural log or the common log. So I'm going to go ahead and say the log of 2 equals t times the log of 1.05 when we bring that exponent down. So really, I then need to divide both sides by the log of 1.05. And then I definitely would need my calculator here. So I would type in the log of 2 divided by the log of 1.05. And I end up getting 14.2. So it is whole number of years, and we would need to round that up because if I only left my money in there for 14 years, it would be less than doubled. So this would have to round up to 15 years. So for those of you that are currently in Algebra 1, or Algebra 2, I should say, you'll learn about logs later this year. So if you didn't know how to do this, you have a couple of options. If this were a multiple choice question, you can just plug the choices in for t and see which would give you an amount that was doubled. Or you can just pick a number for t, like maybe you say, and we're just going to do this with trial and error, pick an amount of time equal to 10. So when we do that, we would just plug in 10 to this original equation over here. So we would do 1,000 times 1.05 to the 10th power, and that amount of money would be $1,629 roughly. So that's not quite double. So we know it needs to be more than that. So maybe we pick time equal to 20 years. So we plug 20 in for t. So we do 1,000 times 1.05 to the 20 power. That gives us an amount that's $2,653 roughly. So that's well over double. So then we need to backtrack a little bit. So then maybe we go to the halfway point just to see what that would be and plug that in. So we've got 1,000 times 1.05 to the 15th power, and that gives us $2,079. And maybe we're concerned here that this is over 2,000, so maybe 14 would work. We can test 14 just to see. So 1,000 times 1.05 to the 14th power, that gives us 1,979.9, so really $1,980. So not quite double. So it's definitely t equals 15 just by trial and error. So just another option if you forgot how to use your properties of logs or if you haven't learned them yet. So here you have an example where it says water in a glass loses 20% each day due to evaporation, and you start with 12 ounces of water, and you want to figure out after how many days it's going to contain 7 ounces or less. You could write an equation to model this scenario, but I think that a lot of times we maybe are a little bit uncomfortable with that just because we have a hard time writing an equation from our problem. You can just make a T-chart that gives you the day and the amounts, and then figure out how long it takes to be 7 ounces or less. So on day 0, or on your start day, you start with 12 ounces of water. So then after that, on day 1, your glass loses 20%. So that means it's retaining 80% of the amount. So we retain 80% of the 12 ounces. And so then I can just type that into my calculator. And I have 9.6 ounces. So that's not 7 ounces or less. So I need to move on to day 2. So day 2, it's still losing 20% a day. So that means it's retaining 80% of 9.6. So that's at 7.68. So then at this point, you can probably assume that it's going to be on day 3, but we can just double check. It's again losing 20%, so we're retaining 80% of the previous day's amount, so 7.68 ounces, which is 6.144 ounces. So after 3 days, we're going to be at 7 ounces or less. So here's a quadratic. Like I had said, this is dealing with things like throwing a ball in the air. It's going to take that curved or parabola pattern. So it gives us the model, and it wants to know the initial height of the ball. So the initial height of the ball is just when time is equal to 0. The ball hasn't been thrown yet. So we can figure that out by plugging into the equation. So h of 0 is negative 2.25 times 0 squared plus 4.5 times 0 plus 26.1. And so this is going to be 0. This is going to be 0. The initial height of the ball was 26.1. And so that's kind of like when we talk about y equals mx plus b for linear functions, b is your start value. With quadratics, it's ax squared plus bx plus c. C is your start value. So here it's going back to what I just said, the starting point for any function is that constant term. So with a quadratic, it was c. If you have something that's a cubic function, you're just going to have that extra term. So it's whatever term doesn't have a variable attached. And that's just because all of those other values are 0. This one here, though, when we have the variable in the exponent, we do want to be a little bit careful because anything to the 0 power is actually 1. So here, we'll say, well, I'll add that in here, any polynomial function. Down here, they're talking about coffee mugs, and so C is the cost and M is the number of mugs. We want to know the startup cost. So if we plug in 0 for the number of mugs, 0.75 to the 0 power is equal to 1 plus 450. So here it's actually 451 for that startup cost. So for your assignment, you have 2 sections on Khan Academy, quadratic and exponential word problems, and manipulating quadratic and exponential expressions. Those are both underneath the Passport to Advanced Math.